Hello, everybody. This is Sunday. It's February 5th, and we are moving into week 5 of our online astronomy course. Now, before we get into week 5, there's something very important coming up, and that is your first exam. Exam number 1 covers modules 1 through 4, and you just take the first exam by going to your modules page, and you'll find the first exam between modules 4 and 5. And here I can show you where that is. Here's your modules page, and here is exam 1, right between modules 4 and 5. And it opens up on Monday, the 6th, and it closes on Sunday, the 12th. You can take it anytime you want between those times. Now, it is an open book exam. You're welcome to use your textbook while you're taking the exam. You can also use the homework quizzes. Open those up, take a look at the answers, and in fact, your homework quizzes should really be your guide for studying for the exam. All the information that is on the exam can be found in the homework quizzes. Now, that doesn't mean the exam questions are the same as those in the homework quizzes, but the material is all there. Plus, I ask 1 or 2 questions about the videos just to make sure people are watching those. Now, you can take the exam the first time, you submit the exam, it gives you your score. If you're happy with that, fine. If you'd like to try to improve your score and take it twice, you can do that. Just click, the exam again and take it again. And as long as you take the 2 before the 12th, February 12th, Sunday, that will work just fine for you. If you do take it twice, then I give you the average of your 2 exam scores. Now, the math on the first exam, on any of the exams, is very minimal. You can do it in your head. If you'll feel more comfortable with a calculator by your side, that's fine, but you're not going to need it. Okay, so that is the news about the exam. 35 multiple choice questions on the exam. All right. Well, as you can see behind me, this is the 22nd Street trailhead up in Ogden. It's just a couple blocks from my house. And I took this one beautiful spring day a year or 2 ago. But we are going to be talking about that object we're most familiar with, and that is Earth, our home planet. Astronomy is the science of everything from the center of the Earth on out to the edge of the observable universe. And so it's only right that we start with Earth. So Earth is this big ball of rock and liquid water. And you'll read all about the history of the Earth. How did it get that way? How did these mountains behind me get there? Were they always there? And in fact, if you live in Ogden, just by looking at the Front Range, we can see signs of erosion everywhere where rocks have tumbled down. All of our beautiful national parks here in Utah are about erosion, where wind and rain have eroded rocks over millions of years and billions of years and cut down through the rocks and left these fantastic rock formations that we have. So testaments to the age of the Earth are all around us here in Utah. And today we have determined that Earth is about 4.6 billion years old. 4.6 billion years old. Now, we'll leave how the Earth formed, how our planet formed out of a huge cloud of gas and dust for a later module. But we're just starting with our planet and looking at how our planet changed throughout its 4.6 billion year lifetime. Now, 4.6 billion years, that is a long time. How do we put that into perspective? How do we compare that with our human lifetimes? Well, I want you to suppose that you have a little paper tape, the type that unrolls, little narrow paper tape, and you were to wrap that all the way around Earth's equator. And on that paper tape is written the life history of Earth. So the question is, where does your story start? I'm assuming that you're age 21, thereabouts. So how much of that paper tape is about you, took place during your lifetime? And the answer is about 4.7 centimeters. Not even 2 inches. So about that much of that paper tape tells your story, that paper tape that winds all the way around the atmosphere. Well, how about the last 2,000 years or so? The last 2,000 years, the entire history of the last 2,000 years would be on the last 4.4 meters of that tape. The last 4.4 meters. And remember, a meter is about a yard long. In fact, a meter, if you want to know, it's 39.37 inches exactly, but it's about a yard long. But the last 4.4 meters are the last 2,000 years. Let's go back further. Let's go back as long ago as there were upright creatures, hominids, those creatures that we ultimately are the descendants of. How long ago was that? Well, if we look at the story of when these creatures were on Earth, and we would later evolve from those creatures, their story occupies, all the way from them to us, occupies only about 8.9 kilometers, about 5.5 miles. So that's their life story. And all the rest of that paper tape that runs all the way around the Earth, detailing all the things that happened to the Earth during that time, they're not concerned with us. We didn't exist yet. And even if you go back to the time of the dinosaurs, even that would take up much more of the paper tape, but a lot still left over. And so you'll be learning something of the history of the Earth in this module. Now, Earth has a solid interior. Here, not talking about, this is below the ocean basin, so we do have water, and but we do have a solid interior of the Earth. It has a thin crust of the lighter elements like silicates, and below that is a mantle, and a mantle is slowly oozing. There's hot material that rises up because it's a little bit less dense, and it cools off, and then that colder material sinks back down and heats back up again. And that slow process is called convection. And the slowly convecting mantle carries the crust along with it. The crust is floating on the mantle. It's lighter than the mantle. It's less dense than the mantle. So it's just floating there. And as the mantle slowly moves in these convective motions, It carries the crust with it. And that causes tears and rips in some part of the crust, and the other part of the crust comes together. And those collisions can form mountain ranges. And below the mantle, there are two cores. There's an inner solid core and an outward liquid core. And this is where the heaviest stuff is settled. You know, Earth was once completely molten. And so the heavier elements settled to the center, and the lighter elements floated to the surface. And so the center of the Earth is made of heavy things like nickel and iron. And at the very interior of the Earth, the innermost part, it is made of the heaviest stuff, and the pressure of all the weight of the overlying Earth, gravity pulling that weight down on the central core, means that it's solid. Now that pressure decreases as you go out, and so the outer core is liquid. It's molten, but it's a liquid. How do we know this? Well, we know by studying the waves of earthquakes. There are earthquake waves, seismic waves, and they travel through Earth's, and we have stations that pick up those vibrations, and they're able to determine just by looking at how long it took a wave to travel from point A to point B over here, how long that took. They can figure out what the interior of the Earth looks like. And we know that it has the structure that I've described. Earth also has an atmosphere. And the atmosphere seems like it goes on forever. And in fact, it doesn't. It goes on for about 100 kilometers, couple hundred kilometers, something like that. And then there is no more. And that seems like a lot. Oh my gosh, it seems incredibly large. But if you could condense Earth's atmosphere down to the density of water, it would occupy the same amount of volume that the Mediterranean Sea does. And you know that we've really managed to pollute heavily the Mediterranean Sea. And so it should come to no surprise that we've been polluting our air. I mean, we in Utah certainly know that we have these air pollutions because of an inversion, but the whole atmosphere has been being polluted because ever since we've been burning fossil fuels, we have been artificially changing the composition of Earth's atmosphere. And slowly, the amount of carbon dioxide has been increasing. And we've known for 100 years that that carbon dioxide, a layer of carbon dioxide, can act as a blanket and trap in Earth's heat and cause a warming effect that produces climate change. Now, it wouldn't be great if we could entirely get rid of Earth's greenhouse effect, because then the average temperature of Earth would be below freezing. So fortunately, we do have some carbon dioxide in our atmosphere that keeps Earth's average surface temperature above freezing. Mars, we'll find out, also has a pure carbon dioxide atmosphere almost, but it is so thin that it can't warm its surface above freezing, the average temperature above freezing. But when we talk about Mars and Venus, both of which have carbon dioxide atmospheres, we can compare them with Earth's. But the dangers of climate change are real, and they are happening. And there are some interesting readings about that in the resources that I've given you to read for this module. And especially, I want you to take a look at something that was written, I think, back in 2018, 2019. It's about what is expected to happen in the American Southwest. And they made their predictions, and you can just go check, 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 because here they are. Well, a lot to talk about, a lot to learn about this wonderful, amazing planets that we call Earth. And hope you enjoy learning all about that. Now, before I go, I will take a look at Stellarium. So let me pull up Stellarium here. I'm going to share the screen, pull up Stellarium. And I did go out on last Monday night, when it was so cold. I could look out. I did see a few stars. So I looked out and I used my app to try to find the green comet. Comet C 2022 E3ZTF. And the moon was just too close to the comet. I took some photos. I knew where the comet was because I was using the little app for my smartphone that I told you about last week. And I knew that the comet was within the field of view of my camera. I took a bunch of pictures. Not a thing, not a thing. There may have been one little pixel that was a little bit bright, but the comet was too dim and the moon was too bright. Now, this is showing you when I think the best night this night is going to be, because the comet is now moving away from the sun. It's moving away from Earth. And that means it's getting dimmer and dimmer. It's also getting lower in the sky each night. Right now, it's pretty high in the sky. It's about 75 degrees above the horizon, like that. And this is Stellarium is looking right now, just a little bit south of west. And this shows what you can see on Tuesday night at about 9:30. That is supposed to be the best time. And you can orient yourself just by looking over here, more to the south in the sky. You can see Orion. So here's Orion. That's an easy thing to find. You can follow these three stars in Orion's belt to Aldebaran, this bright star. Just going up and to the right of that a little bit, there's Mars. And Mars is easy to see because it has this distinctive rusty reddish color. And then up here, there's another bright star, Capella. And right between these two, right between Mars and Capella, is the comet. So if you go out this time on Tuesday and there's no clouds in the sky or it's clear in that direction, just scan the sky about halfway between Capella and Mars, and that is where the comet should be. I'm going to go out. I'm going to head up as far as I can toward Monte Cristo. The road is closed. I think it closes around Ant Hill Road or something like that. But I'm going to go up a ways because looking north from there, I've been up there many times, and I know that looking north, the skies are pretty dark. So once again, I'm going to try to get a picture of this spectacular green comet. Now, if you want to know when bright skies and dark skies, when's the best time to go look for something, you can always go to a site that I like that's called Ogden Clear Skies. So if you just Google Ogden Clear Skies, it'll tell you the predictions for the next several nights and when it's going to be darkest. Well, good luck seeing the comet. Good luck on your exam. If you have any questions, just let me know. You can email me. You can be happy to set up a meeting either on Zoom or in person in my office. If you're coming in my office, give me a call, let me know, and I'll be sure that I'm there to talk to you. And I hope you do enjoy learning more about this amazing, beautiful planet that we all share and are happy to call home. So until next time, I will look forward to seeing you, and take care. Bye-bye.